What is up, my fellow andronauts? Who here thinks that DHT is just a stronger version of testosterone? Well, I'm here to tell you that DHT has unique benefits that testosterone doesn't have, and this is why it's important to maximize your DHT. You can have high levels of testosterone and still feel like you have low androgen symptoms because your DHT is not on point, and or your 5-alpha to 5-beta reductase ratio has not been optimized. Be sure to check my previous video for that. So in this video, I'm going to explain exactly why DHT is different from testosterone and why you need to maximize it. If you would like to maximize your DHT and just want to get to the good stuff, be sure to get my Maximize Your DHT course to fast track your progress. Link will be in the description. Let's dive into this video. So we do know that DHT is about 10 times stronger than testosterone. This is because DHT has 4 times higher binding affinity to the androgen receptor than testosterone, so it binds much stronger, and also DHT binds 3 to 5 times longer to the androgen receptor than testosterone. It's much more capable of exerting what it's supposed to do, like creating those signals, than testosterone. So even though DHT is 10 times less than testosterone, it's 10 times stronger. So if you maximize your 5-alpha reductase and you have high testosterone and your 5-alpha reductase pool, you will be a lot more androgenic than someone that has a smaller 5-alpha reductase pool because of these bunch of strong androgens. And so here's basically what happens when things bind to the androgen receptor. You have your ligand. So this could be DHEA, androsterone, testosterone, DHT, whatever. It binds to the androgen receptor. You have this heat shock proteins 70 and 90 bound to the androgen receptor. And so when the ligand binds to the androgen receptor, it separates these heat shock proteins so they can actually bind. So now you have this bound up androgen receptor from the cytoplasm of the cell, transporting into the nucleus, binding to the androgen response elements with other co-regulators, and then doing what it's supposed to do, stimulating DNA transcription and all of those kind of good stuff. But you can see it's more complicated than just binding and blah, blah, blah. You have these androgen response elements. There's not just one, there's multiple androgen response elements. There's multiple co-regulators. So what I actually want to show you is that because the structure of your androgens are different, they will bind differently to the androgen receptor. So you have testosterone that has a double bond here, and then you have DHT. And so the difference is it gets rid of the double bond and you have 2 more hydrogens bound to this structure. So dihydro is 2 hydrogen groups different from testosterone. This is the 2 hydrogen groups. And so when you look at the structural differences, this is androstenedione, again with a double bond here, and this oxygen group and this hydroxyl group here is different. So you can see most of these steroids look more or less the same. They have the same structure with minor differences between them. And because they are so similar, they do bind to the androgen receptor, but because they have slight differences, they bind to different affinities to the androgen receptor and they induce slight different configurations, because the androgen receptor binds differently to each of these steroids. So it's the same thing with SARMs. SARMs act on the androgen receptor. And so the hypothesis for how they work, how they are anabolic but not androgenic, is there's 2 hypotheses. The first hypothesis, it presumes that the testosterone-bound androgen receptor and SARM-bound androgen receptor have different co-regulatory proteins, which leads to transcriptional activation of a regulated collection of genes. So basically what it's saying is they have different co-regulatory proteins. If I have to go back, you will see these co-regulators. When you use different agonists to the androgen receptors, it will have different co-regulators. So the things that it do ultimately is going to be different despite binding to the same receptor. The second hypothesis is this hypothesis assumes that distinctive ligand classes have unique thermodynamic partitioning and are expressed in conformationally different states. So as I mentioned, like the androgen receptor binds differently to these different compounds, and this creates the conformationally modifications in the ligand binding domain are induced by ligand binding and might change surface topology, thus modifying protein to protein interaction between the androgen receptor and other co-regulators. So it's complex stuff, but because like the structures of these molecules are different, they induce different changes when binding to even the same receptor. And also, testosterone and DHT induces different androgen response elements. So it's different co-regulators and different androgen response elements. And this is actually why studies have shown that there are unique benefits to DHT that testosterone does not have. So when you give, for example, DHEA or testosterone to a human or an animal, and you inhibit 5-alpha reductase with, for example, finasteride, you don't get the same benefit as not blocking it, right? So there are unique benefits to DHT. A lot of people would say that DHT plays no role in the adult, you only need testosterone. That's not true. DHT is not just a stronger version of testosterone, it's different, so it induces different changes to the androgen receptor and gives unique benefits that testosterone will not give you. So you might be thinking like, well, I'm just going to use DHT. Now that's also a wrong conclusion because there's unique benefits to testosterone and DHT. So if you were to use just DHT, you will miss out on the benefits of testosterone. But if you use just testosterone and you don't optimize your 5-alpha reductase enzyme or you block it, you might miss out on the benefits of DHT. Make sure that your 5-alpha reductase is working properly so you can convert your testosterone and DHEA and androstenedione into the 5-alpha reduced steroids so you can benefit from that. So in the previous video, I've talked about why you should never inhibit 5-alpha reductase, because it doesn't just activate your steroids, it also deactivates cortisol and aldosterone, activates progesterone to create allopregnanolone. 5-alpha reductase is very important, not just for creating DHT. So there you have it. DHT does play a unique benefit in the human body because it binds differently to the androgen receptor than testosterone. So I hope you learned something new. So again, if you want to maximize your DHT and 5-alpha reductase and the 5-alpha to 5-beta ratio, be sure to get my DHT course. Link is in the description below. I hope you learned something new and I will check you in the next one. Cheers, guys.